Hello everyone, welcome to Abhi online classes. Today we shall discuss Cauchy Mean Value Theorem in the chapter Differentiability. Its statement is, if two functions f of x and g of x both are continuous in the closed interval a comma b, both are differentiable in the open interval a comma b, and the third condition is g dash x not equal to 0 for any point in this open interval a comma b, then there exists at least one value of x, say c, belongs to open interval a comma b such that f dash c by g dash c equal to f of b minus f of a by g of b minus g of a. This is the Cauchy mean value theorem. In this theorem, both these functions must be continuous in the closed interval, both must be differentiable in the open interval a comma b, and g dash x is not equal to 0. These are the three conditions of the Cauchy mean value theorem. Then there exists at least one value of x, that means there exists at least one means greater than 1 or equal to 1 value of x in this open interval. That point we call it as c, such that f dash c by g dash c is equal to f of b minus f of a by g of b minus g of a. We should remember two important notes. First one is, if we take g of x is equal to x, the second polynomial. Suppose if you take g of x is equal to x for all x belongs to closed interval a comma b, then Cauchy mean value theorem converts, that means it gives Lagrange's mean value theorem. If we take g of x is equal to x, then Cauchy mean value theorem gives Lagrange's mean value theorem. How we will see now. For example, g of x is equal to x. On differentiating on both sides, g dash x is equal to derivative of x is 1. With respect to x, we are differentiating on both sides. G of x is equal to x implies g of b equal to b, g of a is equal to a. G dash x is equal to 1 implies that g dash c is also equal to 1. On substituting in place of x, we are replacing x by c. Then substitute all these values in the Cauchy mean value theorem. F dash c by g dash c is equal to f of b minus f of a by g of b minus g of a. Now we substitute. F dash c by g dash c is 1. F of b minus f of a by g of b value is b, g of a is a. Therefore, this implies f dash c is equal to f of b minus f of a by b minus a. Likewise, we can convert Cauchy mean value theorem into Lagrange's mean value theorem by taking g of x is equal to x. Whereas second note is, Cauchy mean value theorem cannot be obtained by applying Lagrange's mean value theorem to the functions f of x and g of x separately. That is, for applying Lagrange's mean value theorem to these functions f of x and g of x separately, we will get first we apply Lagrange's mean value theorem for the function f of x. There must be these two functions are continuous in the closed interval a comma b, both are differentiable in the open interval a comma b. First we apply Lagrange's mean value theorem to the function f of x. So on applying Lagrange's mean value theorem for this function, f dash c equal to f of b minus f of a by b minus a. Here we take c as a c1, where c1 belongs to the open interval a comma b. Now we apply Lagrange's mean value theorem to this function g of x. Separately we are applying. Then we will get g dash c is equal to g of b minus g of a by b minus a. Here we take c as a c2. Here also c2 belongs to the open interval a comma b. There exists at least one value. No? Now on dividing these two, f dash c1 by g dash c2 is equal to this by this. Cancel b minus a. F of b minus f of a by g of b minus g of a. It is looking like a Cauchy mean value theorem. But here, very important note is c1 is not necessarily equal to c2. These two values may not be equal in some cases. That is why you should not apply Lagrange's mean value theorem for these two functions separately. These are the two important notes regarding Cauchy mean value theorem. See some problems. Verify Cauchy mean value theorem for the functions f of x is equal to x square and g of x is equal to x cube in the closed interval 1 comma 2. Given f of x is equal to x square and g of x is equal to x cube. Both are polynomial functions. Therefore, obviously they are continuous in the closed interval 1 comma 2. Both are derivable or differentiable in the open interval 1 comma 2. These are the two conditions of Cauchy mean value theorem. Whereas the third condition, for the third condition we have to differentiate g of x on both sides. On differentiating with respect to x, g dash x is equal to 3x square. G dash x is equal to 3x square. This is not equal to 0 for any point x in the open interval 1 comma 2. On taking any value in between these two, 3x square is not equal to 0. These three conditions of Cauchy mean value theorem are satisfied. Therefore, by Cauchy mean value theorem, there exists at least one value of x. Say that x value, we take it as a c, belongs to the open interval 1 comma 2 such that f dash c by g dash c is equal to f of b minus f of a by g of b minus g of a. We also find f dash x on differentiating both sides with respect to x. F dash x is equal to 2x. F dash c is equal to 2c. G dash of c is equal to 3c square. In this interval, this is a and this is b. So f of b means f of 2. F of a is f of 1 by g of 2 minus g of 1. So substituting a 1 and b 2. Now we find out f of 2 value. F of x is equal to x square. F of 2 is equal to 2 square. That means it is 4. Cancel c. 2 by 3c is equal to 2 by 3c is equal to f of 2 here is 4. F of 1 is 1 square, that is 1, by g of 2 minus g of 1. So we have to find out those two values also. G of x, x cube. G of 2, 2 cube, that is 8. G of 1, 1 cube, 1. This is 8 minus 1. So therefore, 2 by 3c is equal to 3 by 7. On cross multiplying, 9c is equal to 14. Therefore, c is equal to 14 by 9. Approximately this value is 1.555, a non-recurring decimal. Obviously, this belongs to the open interval of 1 comma 2. This value lies in between 1 and 2. Therefore, there exists at least one value. Therefore, Cauchy mean value theorem is verified. We must get at least one value of x. One value or more than one value in this open interval. So we got one value, that is 1.55 in this open interval. So Cauchy mean value theorem is verified. We look into another problem. Verify Cauchy mean value theorem for the functions f of x is equal to e power x and g of x is equal to e power minus x on the closed interval a comma b. Given f of x is equal to e power x, g of x is equal to e power minus x. Both are exponential functions. In the previous problem we have seen polynomial functions. Now we have taken exponential functions. We know both f of x and g of x are continuous in the closed interval a comma b. Both are differentiable, derivable in open interval a comma b. These are the two conditions of Cauchy mean value theorem. One more condition, third condition, g dash x. We find on differentiating on both sides with respect to x. E power minus x derivative is minus e power minus x. Therefore, obviously this is not equal to 0. G dash x is not equal to 0 for any x belongs to the open interval a comma b. By substituting any x value in here, this will not be 0. These are the three conditions of the Cauchy mean value theorem. Three conditions are satisfied. Therefore, by Cauchy's mean value theorem, there exists at least one value of x. We call this as C. Say C belongs to the open interval a comma b such that f dash c by g dash c is equal to f of b minus f of a by g of b minus g of a. We find out f dash x also on differentiating both sides with respect to x. F dash x is equal to derivative of e power x is e power x itself. F dash of c is equal to e power c. G dash of c is equal to minus e power minus c. Here in this interval, a is a itself, b is b itself. No need of replacing a and b. Now f of b means e power b. F of a, e power a. G of b, e power minus b. G of a, e power minus a. Now on bringing to the numerator, minus e power 2c. E power b minus e power a, this is numerator. This is e power minus b. We write it as a 1 by e power b. This as 1 by e power a. Minus e power 2c equal to e power b minus e power a by, take LCM in the denominator, e power a into e power b. This is e power a minus e power b. Minus e power 2c is equal to, we cancel e power a minus e power b in this, minus 1 times. So minus 1. So on taking reciprocal, bring to the numerator e power a into e power b. Cancel minus on both sides. E power 2c is equal to e power a into e power b. This is equal to e power a plus b. A power m into a power n, a power m plus n. When bases are equal, exponents are also equal. 2c is equal to a plus b implies c is equal to a plus b by 2. This is the arithmetic mean of a and b. So clearly c belongs to the open interval. A plus b by 2 lies in between a and b. So therefore there exists one value. In this interval there must exist at least one value, equal to one value or more than one value. So in this problem we got only one value in this open interval. So C, arithmetic mean of a plus b, that is a plus b by 2. Definitely this belongs to this open interval. Therefore Cauchy's mean value theorem is verified. First we must observe these two functions must be continuous in the closed interval, derivable in the open interval, and g dash x is not equal to 0 for any x belongs to this open interval. If these three conditions are satisfied, then by Cauchy mean value theorem there exists at least one value of x, say c belongs to the open interval, such that f dash c by g dash c is equal to f of b minus f of a by g of b minus g of a. So by taking this theorem we found out the value of c that is lying in this open interval. Therefore Cauchy mean value theorem is verified. Hope you understood this class. There are so many problems are there in the textbook. You can go through all those problems. Hope you understood. Thank you.